Okay, welcome everyone. I'm Albert Franzi, data engineer lead at Typeform, and here I will be talking about how are we using Spark streaming in Kubernetes with ArgoCD and Spark operator. The thing now is that we'll cover different points. We will start talking about the Spark context. So where are we nowadays, no, and what we have, which tools we have in place. Then we will cover about Kubernetes, when Spark met Kubernetes, no, which tools provide it, no, and what capabilities. Then we will cover how to deploy it, how are we deploying into Kubernetes at Typeform, and finally we will share some learnings. But first of all, I would like to introduce myself. As I said, I'm Albert Franzi, data engineer lead at Typeform. I'm leading the data platform team, a cross-functional team conformed by 8 people. But previously, I was working as a data engineer in different companies. No? We can list them as Alpha Health, Shifted Classified Media, and Trovit Search. Also, if you want to read some of my articles, you can go to Medium, to Albert/Franzi, or Twitter, you can follow me at franzi.cross. Even that the content on Twitter is 50% Catalan, 50% English, but I'm sure that the English one, everyone could take advantage of it. Then, about Typeform, where I'm working right now. Typeform is a global company focused on providing meaningful conversations, no, through forms and surveys. No, it's a good company to work on. We have the privilege to try new tools and new technologies. That's why we were able to start playing with Spark in Kubernetes, no, and also using Argo and different tools. So this is really a good company to work on and to test the latest changes once they are alive. But let's focus on what matters, no, the talk itself. So Spark. The thing is that, as you know, I don't know your background, no, the ones that are listening, but I remember now when I started playing with Spark, it was more or less around the version 1.6, no, some years ago. You were able, no, to play using the local Wilker in your machine. Then you were able to play using a standalone Spark, no, where you have some different workers, and then we were moving forward. No, I remember it was Spark 2.1 more or less, where we were start playing with Yarn in an on-premise cluster and using Puppet to deploy it. So it was not the best experience, but still it was good to learn, no, and good to see all the challenges that was bringing a Spark to the community. Also, it was good, no, that Amazon released the EMR option, the Elastic MapReduce capability, that with just one click you could have ready to go Spark cluster, no. And recently, since Spark 2.4, we have the Kubernetes option where we can use, no, different advantages that I will be talking on the following slides. But also let's focus, no, on what we use nowadays or what we use it in the past to execute Spark, no, in different clusters or in different environments. As you know, we can have Luigi and Airflow. Both are really good orchestrators, no? Luigi provided by Spotify, Airflow by Airbnb, both open source tools. This is really good. They are really good, but from my experience, they are good for batch processing, no? When we want to run Spark jobs in a batch way using cruns or different triggers. No? For Spark streaming, it's possible, but it's not the best tool that we could use. Then I know that some people, more old school, is using a batch. They have a lot of batch scripts to run their own pipelines, their own Spark pipelines, not also the best way, a bit old school, but we will respect it. And then there is some aliens, no, some weird people using Amazon Glue. Amazon Glue is really good to have a metastore on the cloud, Hive metastore, so you can like synchronize some partitions if you are using Athena, if you're using Presto, Spectrum, different tools, but not the best tool to orchestrate your Spark jobs. And then the important thing here, what matters is Spark in Kubernetes. Now, this is really a new tool, a new feature, and for us it was a change. No, it was another level. So let's focus. Let's keep talking about this. So what happened when Spark meet Kubernetes? No, let's bring before some insights. No, as I told about the Amazon EMR. So what happens with Amazon EMR? No, first of all, when you try to play with EMR, no, is that you have to wait. No, it's the first impression that you get. No, one example is that Spark 3.00, no, it was released on June, July, and then we need to wait until September for Amazon to release this version. No? So if you are really attached to an EMR cluster, you have to wait until you can use it. It's true that you have time to develop. No, you can start developing in your local machines. No, and then once Amazon release it, then you can start using it because your code is ready, but not the best approach. Also, you have a Spark fixed version per cluster. What it means is that I will talk later about this, but imagine that you have different projects and different teams. Each team has their own velocity. No? So if you start with Spark 2.1 or 2.4, then it's like if you want to create a new cluster to start playing with a new version, you have to have two clusters. No? That means more cost. No? You are paying two clusters at the same time because you are not capable to move all the previous work to the new version. So that means more money, and it means more maintenance. No? DevOps people keeping an eye on the cluster and different stuff. Also, as everyone is aware, no, having an EMR cluster up, it means that you pay for the hours that the cluster is up, not for the usage itself. It's true that you can launch a new EMR cluster and then destroy it once you are done with your job. But even doing this, you have to pay these 15 minutes or 10 minutes that it takes to be ready for you. No, that's also one setback from using EMR. And also one important one is having the same AM role shared across the entire cluster. It's true that even having the same AM role, you can manage to use other roles, no, assuming a role before you launch a new job, or using Amazon keys, no, for each role. But what it means is, for security reasons, even that you have different EM roles, well, you are assuming different roles in the same cluster, it means that other jobs can also assume the other jobs, the other roles. No? So it's not the best approach. One example here, it will be, imagine having a machine learning team, having a finance team, and having a data platform team. They are touching, no, different levels of sensitivity of data. No? Maybe one is touching all the invoices of your company. The other one is touching, I don't know, imagine health records. And the other one is just handling normal data, no? User behavior data from tracking. You don't want to use the same role, no? Because you want to be sure that each team only has access to their own data. So you will end up having 3 different EMR clusters, no? 1 per role. And then imagine that they have different Spark versions. Then it's 3 clusters, and then multiply this for each Spark version that you want to have into production. Not the best environment, as I said. No, so here is when we start playing with Kubernetes. No, we were really lucky, as I say, to be able to investigate, research, and at the end put it into practice and production. This solution, no? Spark in Kubernetes. The good part about Kubernetes, you can have multiple Spark versions running in parallel. You don't need to be fixed in one. You can have anything that you want. Even if you want to try to run a version of 1.6, you could, maybe only using a standalone approach, not the cluster approach. But even that, you will be able to do it. Then one important thing is use what you need, share what you don't. As I said, a Kubernetes cluster has different nodes, and then you request on demand. If there are nodes that are available, you will be able to use it. If not, other people or other needs will be using these resources. One use case that we are experiencing right now is that we have some nodes with APIs, and then we have some nodes with Spark pods. Also, one point that you can take advantage of Kubernetes is that you can use node affinity. So you are able maybe to configure different Spark jobs inside the same node affinity than some APIs. So they are closer. So you know that the latency between Spark jobs and the APIs that you need to retrieve some information, imagine machine models, it's going to be lower. So it's going to speed up your processes. Also, you can have different EM roles per service account, ARSA, it's called. I will talk later about this topic also. That means that, as I was saying before, you can have finance, machine learning, and data platform running in the same Kubernetes cluster and be guaranteeing that each team is using their own role and they are only accessing the data they should, not other. So that can help on avoiding undecided usage of data between teams, even that maybe they are the same company and we should trust our teammates, but it's always to be sure that everything goes fine. Also, you can have different node types, as I said. One thing that we have is that we identify that we can have some small nodes powered by small machines, and then only when there is a huge, big Spark job that needs to be run, then we can request a big machine to be included in the cluster. So imagine that you can just, in case of Amazon, you could have M5 machines, large, and then if there is a new big job that enters to the cluster that doesn't fit in one node, that automatically it can request X large or 2X large. That's really good because then it's like you can handle better the resources that you are using in your cluster. And also at the end, it's money. So it's better for everyone. And at the best part also is defining your own Dockers. I was saying when you are using EMR, you are attached to the Amazon release. So you have to follow their rules. By using Docker, you can use whatever you want. You can vitaminate your Dockers. You can put some processes inside the Docker, and you can have also your own libraries inside it. Imagine that you have a really big, library that you don't want to ship it in all your jars, Spark jars. So you just ship it inside the Docker, and then it's usable by everyone. They don't need to compile it inside. That could be an option. We are not doing this, but will be possible. So what do we need to use Kubernetes? We need a cluster, first of all, starting from 13, then an EM roles. Here is what I said before. I will recommend to use ARSA, EM role service account. It's possible to define some mappings between a service account and the role that can assume. So you don't need to touch any Amazon keys or to assume any role before starting your job. Everything will be handled by Kubernetes. So it's less things to worry about, less nightmares. So that's nice also. And one thing here, to be able to use ARSA inside your Spark jobs in Amazon, you will need to update the SDK version that comes with by default with Hadoop 3.1. In that case, you will need at least the 788. This one is the one that comes with the Web Identity Token Credentials provider. Before it wasn't, and the thing is that it includes the builder function that it can be used with the credentials chain that Spark will be using to access the jar. I will explain why. And then the Spark Docker, you need Hadoop. At least I will recommend the 3.1, the Amazon SDK, Scala 212, the Spark 3, and Java 8. And then here I attached the Docker files that we're using to build our own Spark image. feel free to use it. We believe that it's at least the less that you need, so it should be okay to use it into production. So how do we deploy it? No, I explained some context. I explained how Spark met Kubernetes. Now let's go. How do we deploy this in an easy way, in a friendly way, to production? First of all, let's introduce Spark Operator, an awesome project developed by the community. So I would like to first say thanks to all the people that is behind this awesome project. No, I believe that it's a huge difference between what we had before, no, using a yarn, EMR, any resource negotiator, to be able to use a Kubernetes cluster, no, without wandering and with the capability to use different versions and speed up our deliveries. So at the end, what it does is Spark Operator. It provides you the option to define a Helm spec, no, where you define different properties, and then it takes charge of deploying it into the cluster and negotiate with the Kubernetes cluster for the resources that you need to run this operator, this job. So here is an example of how it looks, the Spark application spec. No, I just split it in two because it was a bit longer, but at the end it's quite easy to read and understand. There are more properties that you could add, but these ones are the minimum that you will need. There is a page, I will share later the link, that is cover all the specs that you can use to define it. Things that you have to keep in mind. The namespace, it's hard-coded it's bold, it's highlighted in bold. The namespace, it will define the namespace of the Kubernetes and also the service account. No, as I said before, you can use ARSA, no, AM role service accounts mappings. So instead of using the default one, no, the service account default, let's use the one that you need to run it. No, so you can have like service account machine learning, service account data platform, service account finance, service account, wherever you have to define it. No, there is also some, you can define the image that you are going to use, the base image of the Spark, also the policy, the secrets. Imagine that you have your Docker, it's not public, it's not in the Docker Hub, you have Artifactory, Quayo, Amazon, Docker repository, you have anything. So you can specify and use, and also you can define the secrets that you need to go, no, to use to retrieve this Docker. Also, let's check this Hadoop conf. As I'm saying, we need the web identify token provider. This one is the key of our success in a Typeform. No, there is different options when it comes to use Spark. No, Spark in Kubernetes. You can deploy the jars inside the Docker. So every time that you build a Docker image, you put the jar inside. So you know that this jar includes your jobs. Or the best, this is a lot of usage of Artifactories. No? Or the other option is you upload your jars into S3, and then by using the web identity token that is already integrated in the core of Spark, you can launch applications. So your Docker never change, only if you want to update to the new version of Spark. And then you just put where is the jar located in S3. Then you can have different arguments and then define it, the driver and the executor. If we go now to the operator, I talked about the schedule. You can schedule it. No, I was saying that in our past we were using Airflow and Luigi. We are still using Airflow, but also one capability that it provides is that you can say, okay, run every 5 minutes. And then you can define the concurrency policy. It's like allow, forbid, or replace. Allow is that you can have multiple jobs running in parallel. Imagine that you say every 5 minutes, but your job takes 7. So during 2 minutes, you will have two jobs running in parallel. The forbidden, it will forbid to run the second until the first ends. And the replace, it will kill it. No, it will not allow to follow the execution. Then also you can have some restart policies in case that something goes wrong. You can say never. So that's maybe the recommended one when you are testing. Don't put always when you are testing, because I'm sure that you are going to go to a crash loop. On failure, that's really good. No, you can define, okay, restart after 3. No, you have 3 lives. Every time that you crash, you lose 1 life. And at the end, it's stop restarting. Or always, you don't care about the result. If it fails or if it succeeds, you will start again. One advice here is that if it gets killed, your job, try to monitor it. Try to integrate it with Datadog or Prometheus or any other tool, because otherwise, maybe if you enter in a loop of crashes, then you will not notice, because you will not receive any alert on that. So having alerts is a good recommendation. So how do we have it here? What is the flow that we are using at Typeform? We make a pull request. Once all the tests and everything is approved, we merge it. Travis detects this merge, and it does a SVT assembly. It puts into S3, and then Argo, it detects some changes in the specs, and then it starts deploying it into Kubernetes, not this jar, using the jar that is already in S3. And that's all. It's really simple at the end. It's not difficult. When I was preparing this talk, I was saying, whoa, at the end, this is really easy. It's not difficult at all. But let's talk about that. So how we can deploy it manually. No, I just explained how to do it automatically. Now manually, just when you are testing, you can do SVT assembly. No, it will provide the assembly jar. Then you copy it to S3, as I say, and then you just run kubectl apply, no, and the YAML that you defined before that I explained in the previous slides. Once it's done, or when you are done, just delete it. Always keep the cluster clean. Don't leave trash on the cluster. And what is Argo? Argo is a declarative GitOps continuous delivery tool for Kubernetes. It's really easy to use. It's quite friendly. It's more or less to what was Spinnaker, no, in the past. But I believe I was using Spinnaker and Argo, and I believe that Argo is more friendly and easy to use. At least the learning curve is faster. And at the end, you define some specs, and you can start using it. No, the only spec that you need to use is that one, no, the Spark application project. Sorry, the Argo application. And here you have all you need. You don't need anything else. You can define some values, the repo where you have the code, and Argo will scan for changes. Now, once they detect some changes, then it will deploy the new specs into production or development. No, at the end, this is how it looks. You have here we have right now 3 Spark applications running real time. No, in that case, for the example, I just put 1 worker and 1 executor. No, we have the master and the slave, just to keep it simple here, but you could have more. And also you can synchronize only the application that you want, or all the set of applications that are defined in this repo. So that's it. No, I covered the different options. Here is how it looks. I hope that you understand it. We can talk later in the Q&A, but at the end, it's that simple. No, we merge to master. Travis triggers the build, and it loads the build into S3. Argo detects that there has been a new version, and it deploys to Kubernetes. You can put this automatically, or you can configure it to be manually, just to maybe avoid some people putting automatically changes into production. At the end, you can put a human behind, but keep in mind that you can also put it automatically, so you just forget. So let's go to the end. Now, some learnings. As I said, it was really easy to set up, but with the right team and the right infrastructure. No, we were quite lucky to have a DevOps embedded in my team, no, in the data platform team. I know that some people have, some companies have an infrastructure team outside the team. In that case, it was really crucial to have the DevOps inside the team, as at the end is one of us. No, so also he knows a lot of data. So it was easy to set up everything, to put everything in place in an infrastructure way. thanks to him. As I say, when I was preparing all this talk, I was saying, oh, I'm not sure if that's a high level or low level, but at the end, it's really easy. It was really easy to adopt for the team, and also with the other teams that are in the data area. We can have different versions running in the cluster. We have different needs and roles. So that was good learning about moving from EMR to Kubernetes. Also, it's like we always have a Spark testing cluster always ready. It's there. You don't need to wait until the EMR is ready, and you just run it. And if there are no enough nodes, you will need to wait some minutes. But if there are, you will be able to run. And also, I'm using a Lens, a really good company that allows a really good product that allows you to monitor all the resources of your pods. And the best learning, I don't know if you are fans of Age of Empires, but adopt a DevOps in your team and convert it into data DevOps. I believe that that's one of the best things that you can do, because if you have some DevOps that really knows how data works, then you are going to be capable of doing this amazing job. So to finalize, thanks to all the team that has been involved. As I said before, this is a cross-functional team. We are 4 data engineers, 2 BI, data warehouse architects, 1 data ops, and 2 tracking specialists. So all this work is thanks to all the team that has been there for all the journey. So I hope that you like it, and see you in the QA. You have here some links that I believe that it could be interesting for you. The 2 Medium posts, one from my teammate Carlos about how to deploy a Spark history server in Kubernetes, and the one that talks about this talk and the specs and some Argo information. So thank you everyone for being here.